All right. Let's chat about fat characterization and tell stories. I know you're tired, so it will be more of interaction and then we can continue on Monday with this topic. All right. So when you hear fat characterization, what comes to mind? What are we characterizing about fat, huh? Type of lipid. Exactly. Can you elaborate? Yeah, so polyunsaturated fatty acid, saturated fatty acid, what else? Cholesterol, potentially? Yes. So what's on the label usually? Saturated. Saturated. I don't see that on the label. What else do you see? Cholesterol. Don't you see cholesterol on the label? What else do you see on the label that could be there because of processing? Trans fat. Yes. So fat characterization, part of it has to do with the types of lipid and how they relate to health. Cholesterol is important to our health, so it has to be on the label. Trans fat has adverse effect on cardiovascular function, so it has to be on the label. So this kind of, what else can come to mind other than the type of lipid? Flavor. So what can cause off flavor? Oxidation. So a lipid rancidity, right? It could be oxidative rancidity. And what is the other type of rancidity? There's oxidative rancidity and there is chemical. Well, yeah, it is chemical. I mean, it's sort of chemical. Both oxidation is also chemical reactions. So what do you call when your triglyceride break down into fatty acid and glycerol? What do you call it, huh? Hydrolytic.
Oh, yeah.
Yes, it's increasing in molecular weight. I mean, you're not far off, but it's called hydrolytic rancidity. So you have oxidative rancidity, you have hydrolytic rancidity, and those all will impact flavor, which is a combination of taste and odor. So, okay, so shelf life, basically. When we are characterizing fat, we can look at shelf life stability. Okay. Is there anything else you can talk about that person?
Okay, so it's more saturated, it's more prone to liquid oxidation.
The more polyunsaturated. So the more double bonds you have more prone to oxidative rancidity. But if you have endogenous lipases, for example, you're going to get hydrolytic rancidity. What happens to the oil when you're deep frying potatoes and you use the oil over and over? What do you think is going to happen to this oil? It will oxidize, but what also? So you would also have breakdown of triglycerides into fatty acids. So heat and water that comes essentially from your food, from the potatoes. So heat and water will break down your triglycerides. So you will also have hydrolytic acidity, and now you have fatty acids that are more prone to oxidation than triglycerides. Triglyceride will oxidize, the fatty acid within the triglyceride will oxidize, but free fatty acids are more prone to oxidation. So now we talked about processing. So that deep frying is your processing. Have you heard of the term extra virgin olive oil? What does that mean to you? Extra virgin olive oil.
Is it processed more?
Processed more
Or less?
or less?
Less.
Yes. So extra virgin olive oil, usually you crush the olives, you get the oil, you leave it as is. Then there is refined oil. During refining, you know what we are doing actually when we refine oil? Have you learned about this anywhere in processing, for example? Do they talk about oil refining? They don't? Hmm. Okay. I'll have a talk with Kumar and he'll. Well, okay, so do you have any idea? It's fine that you don't, it seems like you don't cover it.
Is it distillation?
Distillation.
Like similar to how you would alcohol with for oil?
So, not quite. So what happens is when you crush the seeds, those olives or any other sources of oil, so you get this crude oil, and crude oil usually have some amount of free fatty acids in it. So you have triglycerides, but you also have free fatty acids in this crude oil. Could be a result of endogenous lipases that break down the triglycerides during the process, but you have some free fatty acids there. Refining actually gets rid of that free fatty acids for you because you want to enhance the flavor, reduce the potential of oxidation. Then what they do, they actually treat the oil with base, with alkali. So you have NaOH will react with acid, which is fatty acid in this case. What would be the product? Base with fatty acid. What would be the product? Any idea? Soap and water. Huh? What's the flow? I mean, it's kind of, yeah, related, huh?
Slightly negative.
What's it?
Slightly negative.
Slightly negative?
Yeah, you just say soap and water.
Soap and water. So what happens is that once they treat with NaOH, the oil, there is a centrifugation step. So they separate the oil from the soapy water that comes out from NaOH reacting with fatty acid, and they get that fatty acid reacted with NaOH, they get it out, and then your oil will be refined. So your oil will have less free fatty acid in it. So in lab next week, you're going to do, one of the groups will be analyzing free fatty acid in extra virgin olive oil and in refined olive. And you will see that the extra virgin olive oil have higher percent of free fatty acid. Now, why do we have extra virgin olive oil on market and people actually buy it? Do you use olive oil? No.
Is it better for you?
Huh?
Better for you?
Not necessarily better for you.
It's yummy. Why is it like monkey? Like it's like,
Less processed and also tastes good.
yeah.
The olive oil has a characteristic taste. Once it's refined, you lose that characteristic taste of this olive oil. But all other oils on market usually are refined. Like corn oil is refined, canola oil is refined. Yeah, olive oil specifically is has a characteristic flavor. All right, so process. Have you heard of the term winterizing of the oil? You heard winterizing. So it's part of also you refine the oil and then you winterize the oil. What does it mean when you hear winterize?
Restore.
You winter is
Cold.
so cold.
It.
No, we don't have it. We're not hydrolyzing the earth. All right, so
Freeze it. Like cold pressed oil?
yeah, well, not you don't test. You just put it in cold temperature. Why?
So
crystal, yeah, remove all of the waxy material, crystalline, and then your oil will be clearer. So a lot of the oils are used in salad dressing, and then you want to put it in the fridge, and then when you want to use it, if you're a consumer and you're pouring your dressing and then it's cloudy and it has crystals in it, and you're gonna say, oh, it's not good. It's just a quality parameter. So you really want to get rid of those waxy materials by winterizing. And that means just bring the temperature down, let those waxy material in your oil crystallize and separate them. So this is all part of processing of oil that would potentially change the characteristic of what other common processing of oil? not hydrolyzing. It does start with an H. Hydrogenation. I know it. It starts with an H. I thought you knew that. Okay. All right. So hydrogenation. What happens when you hydrogenate? What's that? You add water?
Trans fats.
Is it? Huh?
You get trans fat.
Yeah, incomplete hydrogenation, yes, it gets you trans fat. Incomplete hydrogenation. So hydrogenation is basically, it's a process where you convert the double bonds into saturated and then you add hydrogens to that double bond breaks, and then you have extra hydrogen. So this process is converting oil into margarine, for example. So butter, like vegetable butter. So hydrogenation, if it's done incompletely, the cis fatty acid, usually they are, the double bonds are in cis format in nature. And then if you like certain heat or processing or oxidation or incomplete hydrogenation can cause the formation of trans fat. That's why it has to be on the label. So usually plant-based oils don't have naturally occurring trans. All of the fatty acids are in cis form. In animal fat, you might have a little bit of with trans form naturally occurring. Okay, so those processing can lead to production of trans fat. So fat characterization is really important for bulk oil and for foods that contain oil. So we care about shelf life when you have fat or oil, bulk, or in a food product. We care about the impact of how do we process our oil to enhance their shelf life. A production of margarine, how would that impact the characteristic of oil? So, and then of course there's the safety that could be not only from a presence of trans fat or health perspective, cholesterol, but sometimes oxidation products are not good for us, can be carcinogen or can be inflammatory. So like malonyl aldehyde, for example, or oxidized cholesterol is not good for us. So toxicity. All right, so there you go. So we need to characterize fat for nutrition labeling. So we already talked about the saturated fat, trans fat, cholesterol. This is part of nutrition label. And then whenever there is fat, we care about shelf life stability, whether it's bulk oil or food that contains fat that will cause over storage, or during processing, you might get rancidity. Two types of rancidity, hydrolytic and oxidative. Okay. And then we talked about some processing effect. We can elaborate on more. And then also, we talked about safety, but one thing we didn't talk about is palatability and sensory effect. You know how butter, when you take it out of the fridge, it's hard to spread? But what happens when they add olive oil to the butter? It sounds, yeah, it spreads better because then you lowered your solid fat index or solid fat content. And that helps with spreadability and mouthfeel. So, and also high fat food are better than low fat foods. Try to convince me to eat potato chips that is oven baked. No, if I want to put energy in eating chips, I better eat the real ones that are fried. So definitely flavor and mouthfeel. Okay. Okay. I'll leave Emma alone. You're making her laugh. What's big chicks?
Chips.
Ah, baked chips. It's like big chips. Huh?
She likes that.
You like them? Hmm. It's an acquired taste.
Yeah, it's good.
Yeah,
I like processed foods.
we all do. All right. So yeah, that kind of breaks it down for you in terms of nutrition labeling. Saturated fat is associated with negative health. So they promote the formation of LDL, low density lipo something.
Protein.
Lipoprotein. I don't want to say protein. I want to say yeah, LDL. And then so they're not good for us. And then we talked about the formation of trans fat, and then cholesterol also not so great. Especially for people that have tendency to have high cholesterol in their blood, or people with diabetes, they're more prone to having high cholesterol, so they should have lower intake of cholesterol. All right. We talked about shelf life stability in terms of oxidative rancidity and hydrolytic rancidity. By passing, I said about one endogenous enzyme that causes hydrolytic rancidity, and that is lipase. So lipase is a hydrolase. Hydrolase is one category of enzymes. So it hydrolyzes, breaks bonds, and an H2O molecule becomes part of that reaction. Okay, so what is a naturally also occurring enzyme that can promote oxidative rancidity? I like how everybody head down. No, don't look us in the eyes, fam. Have you heard of lipoxygenase? So it's a naturally occurring oxidative enzyme. So it promotes the oxidation of fat. Of course, oxidation fat can be based on autooxidation that does not require enzymes. But lipase, if you have endogenous lipase and lipoxygenase, that's a goner. You're hydrolyzing your triglycerides, you have those free fatty acids in there, they're more prone for oxidation. You have lipoxygenase, gone. You have all sorts of bad off flavor components that can come out of that. Sometimes we characterize those fat components or those that simulate fat. For example, when we're developing ingredients, you heard of olestra? It simulates fat in mouthfeel and characteristics, but it is not digested in our gut, so it doesn't carry calories. And it's basically a sucrose with 6 to 8 fatty acids. So it's kind of a fat replacer. Sometimes we use monoacyl glycerols. We need to know how much we have monoacyl and diacyl glycerol. They act as emulsifiers and used as ingredients. Okay. All right. Okay, so this, before I let you go, this is the last thing I'll cover is all of this processing of the oils that I talked about. So all plant-based oil, the first step is you get the oil out of the seed. So if it is an olive, you crush the olive. If it is corn, you take the germ. When you're processing corn seeds, you get the germ, and the germ is the component that has the oil from corn. So every source, you have different initial process to get the oil out. And then it has to go through a series of processes, like refining. We talked about adding this NaOH to get the free fatty acids out, and then winterizing to clarify, deodorizing to remove off flavors, and also removing of color. So all of these processes are done, and then you monitor the characteristic of the final product. So how much free fatty acids you have taken out. you end up with zero free fatty acid, that means your refining process has been done correctly. If you're doing hydrogenation, to test your hydrogenation process, what do? You do an initial test for unsaturation, and that's the iodine value. So you can measure iodine value, determine how much is the extent of unsaturation, and after hydrogenation, to ensure that you completely hydrogenated and you don't have any more unsaturation or double bond, you measure iodine value again. So we will learn about iodine value because of those kind of processing. And also iodine value is related to potential of oxidation. The higher the iodine value, the higher the polyunsaturation, the higher the potential of oxidation. Deep frying. Deep frying causes the breakdown of triglycerides to free fatty acids and then oxidation of these free fatty acids. And when you have more free fatty acids, have you heard of the smoke point and the fire point? So the oil can set on fire because when you deep fry, the more you deep fry, use the same oil, you have more free fatty acids. They have a lower smoke point than triglyceride. So then that's a hazard. And I have a story to tell you next time. Okay, we talked about palatability, safety, product of oxidation are toxic. Malonylaldehyde is a straight product from linolenic acid, and then cholesterol can oxidize and give you cholesterol oxide, bad for us. Okay, so next time I will go into the different analytical methods we have for bulk oil, and then measuring lipid oxidation, and then looking at lipid fractions. So to be continued on Monday. Have a great weekend, and I'll see you next week.